Welcome to the 5th tutorial of the online training course MOOC for the tool modePROCON. For this tutorial, the installation of the tool is preconditioned. Up to now, the objectives, the theory behind the tool and the installation procedure should be known to you from previous tutorials. In this tutorial, an application of modePROCON is presented. In contrast to the other application tutorials, this tutorial is dealing with groundwater from porous aquifer. The tutorial is structured in 4 parts. First, the study area is presented and briefly described. Then, the results of a sampling campaign are shown. modePROCON is then used to answer the questions if the detected PPCPs can also be found in the extraction wells and if a model is helpful and whether it can be set up or not. In the end, some model results are presented. Let's start with the study area. The examined study area is located in Neufahrn by Freising, which is 15 kilometers north of Munich in the south of Germany. 3 wells extract water from the shallow aquifer. The wells are displayed by the red dots. The aquifer is located around 4 meters below the surface and is bounded by a clay layer at the depth of 17 meters. The area is located in the Munich gravel plain, thus the water flow velocity is very high as it can be expected for gravel aquifers. Overall, it is a rural area which is mainly used for agricultural purposes, and next to the area the river Isar flows northwards. In the study area, a wastewater treatment plant treats a substantial part of Munich's wastewater and discharges water without an advanced water treatment into the Isar. The river water was sampled in the north of the study area for 5 times. Then the samples were analyzed with respect to the PPCPs which are listed in the modePROCON database. The compounds which were detected in all 5 samples and which exhibited an average concentration above 150 nanogram per liter were considered in this tutorial. These are 4-phenylamino antipyrine, benzotriazole, diatrizoate, and iohexol, as well as iomeprol. Now the question may arise if these PPCPs can also be detected in the pumping wells. For this, modePROCON can be used. So here we go. Let's open modePROCON. First, you have to select the water source. For this case, please click on Evaluation below the groundwater system on the left. Now you can select the PPCPs we're interested in. Please tick 4-phenylamino antipyrine, benzotriazole, diatrizoate, iohexol, and iomeprol next to their names. Then click on Evaluation. As a result, you can see for all the selected PPCPs the compound-specific generated indices for solubility, sorbability, volatility, and decryptability. These values are also displayed in the figure below the table for each selected PPCP. In addition, you find for each PPCP a link for a study dealing with the particular PPCP in the groundwater. The modePROCON algorithm gives also the likelihood of a certain PPCP to be found in the groundwater. In this case, it's very likely to detect 4-formylaminoantipyrine, diatrizoate, iohexol, and iomeprol. To detect benzotriazole, it is likely. This can be explained as all these compounds are very soluble and little volatile. And except of benzotriazole and iomeprol, the compounds show a little sorption capacity. Although iomeprol and benzotriazole can sorb both moderately, they do not show the same probability to be detected in the groundwater. This is related to the biodegradability. Benzotriazole is much better degradable than iomeprol, thus it can be found less likely in the groundwater. As all selected PPCPs are likely or very likely to be detected in the groundwater, it is recommended to set up a model to further investigate the risk of observing a groundwater contamination. For this, please click on Go to Model Requirements. As you can see it, several data is required to model the groundwater flow and the transport of PPCPs in the groundwater. Thanks to previous hydrogeological reports and studies, much information is available for the hydraulic head, the hydraulic conductivity, and the thickness of the aquifer in this case. Besides this, we suspect the river as a source of PPCPs in the study area, and the measured concentrations in the river are also known. The point of interest is in our case the extraction are the extraction wells next to Neufahren. If we tick all the available information and click on Evaluation, the following output can be obtained. The model cannot be built. modePROCON provides the user with a suggestion how to obtain the missing data. In this case, the surface-groundwater interaction can be yielded by measuring the flow between the river and the aquifer by using seepage meters. If we assume to have this information, we can tick on Yes and click on Evaluation again. Now the output is: it is possible to develop a numerical model. For this case study, a groundwater flow model has already been developed and is shown on the left. The groundwater equipotential lines, the black lines, indicate the water level with respect to the sea level. As water always flows perpendicular to the equipotential lines, river water infiltration in the north can be observed. However, it is very unlikely that this water reaches the wells. Even if the river water is elevated by a flood event, it is still very unlikely. Thus, the river as a source for PPCPs can actually be ruled out for this case. Although modePROCON suggested for most of the PPCPs a high probability to be detected in the groundwater. This shows clearly that even a flow model can be very powerful in terms of estimating the risk of PPCPs in a well. However, the shallow wells were analyzed in this project as well, and some PPCPs can be observed in the shallow well at low concentrations. Even though such low concentrations are not a matter of concern and can still be interesting to identify where they could come from. As the river can be ruled out, For this case, another PPCP source might be the reason for this observation. For this, additional transport models are useful to identify the sources.